Graphs tell us things. The slope of a position-time graph tells us velocity. The y-intercept of a position-time graph tells us starting position. The area of a velocity versus time graph can tell us something too, and I mean the graphical area. Listen to this. If you're going 50 miles per hour and you travel at that speed for 1 hour, how far will you go? Think about it. How far will you go traveling 50 miles per hour if you travel for 1 hour? All right, time's up. I hope you realize that you will travel 50 miles in that time, and that idea can be captured in the graphical area of a velocity time graph. And by graphical area, I mean the area bounded by the time axis down low and the line that represents the velocity. So in this case, that's the area. And this area can be calculated by looking at this like a rectangle. Now, because of the scaling on the graph, it looks strange, but this side right here has a value of 50 miles per hour, and this long side here actually just has a value of 1 hour, and the area is going to be the 50, but there are units. That is 50 miles per hour is the side times the length of 1 hour. And that equals, well, 50 times 1 is 50. And if I look at the units, I see that the hours cancel out and I get miles. So 50 miles, hey, that is the area, the graphical area of this graph, and it also happens to be the displacement, or how far this object goes. So this is always true for velocity time graphs. The displacement of an object's motion is equal to the area of its VT graph. That's always true. Here's a couple more examples. Here's an object that travels at a constant 2 meters per second for 3 seconds. The area of this velocity versus time graph is the area within the time axis and the line that describes the velocity. And so the displacement then for this object equals the area. That's the idea. And now to calculate, I would say, well, it's the height, which is 2 meters per second in this case, times the length, which is 3 seconds, and the graphical area is 6, and the seconds cancel out, 6 meters. That is the displacement of this object. Over here, the graphical area is between the time axis and this line that describes the velocity, which is negative, a negative 1 meter per second. And in this case, the displacement for this object is equals to the area within this graph. And that's going to be minus 1 meter per second times 3 seconds. So the displacement is a minus 3, seconds cancel, minus 3 meters. This object moves 3 meters, but in the negative direction. It decreases its position 3 meters. So here are examples of calculating displacement using a velocity versus time graph, and you can always do this.